Here I am starting recursive functions, something right? Yes. Let's figure out why it is not coming. Let's come back. We want to write recursive, right? Let's try with this normal batch mode or script mode. We have one file. If you want to end, right, if you want to come back to our normal programming, :q, and here let's try it nano. We already keep it one file, that next one dot scala. Yes, check it out how I am being writing all these things, or else you can cat the command. Yes, I am writing by starting with the command like object. I can easily specify the things like I am creating one singleton class, and the class name is nested filter, and I am extending the app class whenever to facilitate the application activities. And here whenever I am writing filter as a super function and process as a sub function. Here I am writing a function in another function. Here the function one, first function is the filter and second function is the process. Fine. In this, among all these things, I am writing, let's take it out, what are the requirement. I hope you already explained the requirement. I am giving some list of values and one threshold value. By taking this threshold value, we have to compare each value, and if the value is less than the threshold value or max value, then we have to get the values and we have to return as a list object. Fine. For this only I am taking the things like this as the input. I am taking as the list of integers and the threshold as a threshold. The variable name itself I am taking as a threshold as the maximum value. Fine. And here the process means I am taking the same these list of values. Fine. These list of values I am taking the variable called ys, and again it will returns. We have to take these return values and we are always comparing with the threshold value. And here I am returning the value is list of integers. Is what I am getting the output. Fine. First of all, I am checking with the empty or not. It is empty means we are not doing anything, just we are returning just list of values. What are the values I am sending? Same thing I am sending the things. If I am passing the things means else will be executed, and we are checking whether the head value, head means it will compare as the first interval, it compares the 9 less than 5. If it true or false, it's false. So obviously it will go for the else case, means the process of y dot tail. Here whenever I am using the tail means remaining objects will go to the excess ys of list of integers. Remaining values will go to the process statement. It will be recursive for the process. Here itself I am taking, here also I used the recursion. Again I am using the recursion here in the nested function also. Fine. Again 2 less than 5 it will works, means then the ys dot head, we are adding the head value to our ys dot tail. Now again I am dividing this tail value. If the head value is less than the threshold value means again we are adding to the existing value. If it is not satisfying the condition means we are not adding to our existing tail values and we are getting from our execution procedure. Fine. Like this I am able to execute the process and all the things by using nested functions. Nested functions is nothing but function in a function. We are writing super function and sub function. We are writing two things are there. Here main function is the filter and sub function is the process. All the things all together I am keeping in a class called nested filter. Fine. And the file name I am taking is nest1.scala. I can also change the file name other than the class name also, but the recommendation should be the file name is also have the same name like class name. If I can also give the other than the class name. What else if we give the other than class name? How to execute this class? Using Scala C compiler. What's the file name? nest1.scala. Fine. Yes, we are going to compile this through file name.scala. The thing is, if we want to execute, what's the command? Scala, and here can I pass the next one? No, here we have to pass class name, that is nested filter dot scala. If you give nest means it won't work, you can also check it out. Nested filter whenever we are compiling this nest1.scala, its scala engine will create a nested filter.scala class. For this purpose only we have to give scala nested filter. Let's check it out. What is the output? I am getting the values like 2, 1, 3 as the object like list reference. Fine, it's compare. Initially it compares 9 less than 5, false. 2 less than 5, true. 1 less than 5, true. 3 less than 5, true. 7 and 8 are also not less than 5. For this purpose only we are not adding 9, 7, 8 and we are adding the only 2, 1, 3 to the our output list. Fine. I hope you understand how to work with the nested lists and nested functions. Here also I again used the recursive. We already seen the recursive example. Again here I am using the recursive principle to take the multiple principles like this, like these kind of requirements. Fine. I hope you understand. Let's check it out. Let's execute the remaining things, and I hope you can also execute these things on the script mode. That is what the nested functions. And here we can also use it like main function and all things we already seen, right? Now previously we used arrays, right? I hope you guys are remembered about arrays, how to declare as array and these kind of things. Suppose if you want to create a single dimensional array, how you have created? Create where a1 equal to array of integer, the type, and then we have to specify the size. If you specify the size means we have to use the new keyword, or else you can leave like this itself. Fine. Let's keep the things new of 10. Array, new array, integer 10. Let's figure out why I am getting the error. Check the syntax. Change the variable name. Where I am executing all these things in user environment only. We didn't go to the scala. We just executed the script mode, right? Check it out, the arrays. Where a1 equals to new array and if you want to specify the type, you can specify the type also. A1 is created with a 10 default values. I am keeping the data type is integer. For this purpose only I am getting the data type as 0. Fine, I am keeping the data type as integer. For this purpose only the default value as 0. If you pass the string means we are getting null. We all seen, right? Yes. Suppose if you want to create some two-dimensional array, how you can do it with the scala. We can also create two-dimensional, but three-dimensional, all these things. Let's check it out how you can create and how you can maintain the things. Let's simple, very simple. instead of here we have to pass the what is the row count and what is the column count. Let's here no need to specify the array, two-dimensional array, right? If you can specify with the new win, so you can specify the size. A1 is created. If you want all these things or something, if you want to be create with some existing value like new check it out. A1 is created, right, with a two-dimensional array. If you want to insert the values, how we can insert? A1 of 0, 0. The value is 5. Let's add the multiple values, then I can show you. Here we are giving two values as the row count is 2. Till now we have seen lot of concepts and overriding nature functions, function varieties, all these things we have seen with respect to the classes and objects, some singleton classes. We have seen lot of things, right? Still, if you go in deep detail to the some objects and class structure, still what are the things are there means? We have one concept is there like companion objects. In Scala, what is meant by means? Suppose whenever we are writing the things, suppose we are maintaining a instantiation of a class with the same name like a singleton class, then only we are saying that objects we are calling as a companion classes, companion objects. Fine. Whenever we are maintaining a singleton object in the name as the same name like a class, then only we are saying as a companion objects. We can maintain some of the cases, we have to maintain that all those things. Let's figure out what's the thing or not, how we can let's take the example for companion objects and how to create it. Suppose for this we have to move to the normal mode. We have one file called companion.scala. Let's check it out. This was the example for companion object. Here I am creating an object with the same class name like our singleton class. Fine, I hope you understand. You can also execute and you can get the output. And if you want to execute or something, you can say, you can call whatever it manner. And after onwards, we can also use the something like, I hope you guys are discussed about the inheritance also. Let's check it out once in say inheritance. I hope we didn't use the overriding concept in inheritance. Let's check it out. Suppose I am writing one class again. Yes, I am in the here it's only, right? Let's write one class in Scala mode. Scala, I am writing one class A, and the function name is I want to create it def ABC. This is my function name, and what I wanted to be get it out is println hi. Fine, that is what the class A. And let's go back to the class B. and what I want to is I am using extends keyword. By using extends keyword we can perform the inheritance. I already explained inheritance concepts. And println hello. I am using the same method name which is having the super class name. Now you check it out. Overriding method ABC in class A of type return type. No, see, I already have the return type ABC method in super class. Again here I am using ABC class a super class. For this purpose itself it is going to be override. If you want to really override means you can override it. How we can override? Check it out. If you really want to override means no issue, you can override it by using override keyword. We just closed that class, right? Class A. ABC print. Class B extends. If we clear the screen means previous classes objects those are not unavailable. For this purpose only I am writing again. Class B extends class A. Write the second statement. Here also I am using same method ABC and I am printing. Change this text context as hi. Yes, there is the error we have seen, right? Overriding. Check it out. Same class I am taking. Here in the place of ABC what I am writing is I am taking the keyword called override. If you use the override keyword means it doesn't give any error, it overrides the superclass same ABC method. That is what the job will be done by the override. No, you cannot get the error. Here we have to specify. If you want to override the superclass method means we have to clearly specify override definition and what is the function name. Fine. Now you can create an object for this B class where OB equal to new B. Fine. OB dot we have to create an object, we have to call it right ABC. Now you can check it out. The overrides, the child classes ABC method is overridden by the superclass. For this purpose itself the superclass method is overridden by the child class. For this purpose only I am getting the output as hi. Fine. Here hi is overridden by the output called hello. This is, we can also perform the override, but we have to use the keyword called override. Fine. And after onwards still what are the classes what are the concepts we have mingled with the classes means, and we do support with the abstract classes. How to execute and how to perform all these things means let's check it out. If you want to perform, we want to keep some of the methods as the abstract methods, and if you want to execute, if you don't want to use the public scope means then we can use the class as a abstract class. If you want to create abstract class means nothing, abstract, suppose the class, now it is the abstract keyword abstract class ABC. Fine. Sorry, I didn't give the description, right? ABC1, and here we have to keep the definition, right? Definition even suppose the fun1. I am taking one function 1 and I am not giving the any one of the definition. Like this I am keeping def it doesn't give any error. Why means I am clearly saying this is a abstract class. If we forget about the definition for these two functions also, nothing will be happens, it will be automatically taken out as a abstract methods. Fine. That is what the advantage with the abstract methods. And when I can make use of these abstract methods by extending with the child classes, something like we have to mix these abstract classes with the normal classes. Again we have to write class ABC2 extends ABC1, and here we have to override function 1. What you forget? Override def keyword, def, definition, and same kind of things. Override function 2, and I am getting the value as 2, and I am closing the ABC1 class, ABC2 class. Now I am creating object for ABC2 class. Fine. If we call the ob1 dot fun1, I am getting as 1 output. If I call function 2, I am getting 2. Fine. Like this I can also work with the functions and kind of abstract classes. We do have the abstract class and all this, but we are not supporting with the interfaces with comparison with the Java. Fine, we are not having the interfaces, but we do have the concept called traits. Let's check out the traits will be common related to the interface only. Let's check out how the traits will be having. What is the advantage of these traits? The main purpose of these traits is to encapsulate the methods and fields of the fields definitions. That is what the main thing of a trait. We can reuse by mixing them with the normal classes, and we can check it out with the executions. How to create trait means simple. Trait, and we have to write the class name. Suppose I am taking the class name as xyz. Define trait xyz. Fine. Whatever you want, you can keep it out, and you can maintain the things. And based on the main purposes, if you want to encapsulate, if you want to make use of all these things, means then we have to use the traits. The keyword we have to use it is trait only. You can also use this trait, and we can define the things wherever you want. Fine. Suppose we can leave the definition of the function 1 here itself, and we can go to the child classes, and we can mix those xyz traits, and you can execute the things. The main advantage with means we can add these multiple traits to our existing class. Suppose if you want to access multiple, suppose by using classes we do not support the multiple inheritance. In the Scala also we do not support the multiple inheritance. What is meant by multiple inheritance means, suppose a single class is extending information from two different classes. We do not have this kind of concept in Scala. Fine. How we can perform all these things? Then if the case is there, like if you want to take the parameters or properties from two different resources, two different classes, then what we have to do means we have to use these parent resources as traits. If the A and B are the traits, then you can add how many traits you want, means you can add it to our existing class. If the parent resources are not the traits and they are simply normal classes, means we cannot support the multiple inheritance concepts, like getting the data from multiple resources. Fine. These are the things all related to the classes, objects, traits, and all the things. I hope you understand how the Java, how the Scala will work up with the functional programming and related to the objective oriented concerns. Fine, we have a lot of things, still we have a lot of things are there. Let's check it out previously, and you can give consideration to the normal thing. Like Java itself, we are not supporting all these things like multiple inheritance and kind of things, all these things. In the place of interfaces, we use the traits. However, we are working with the interfaces to encapsulate the things and to work with the multiple inheritance. Here also same reason, you are using work with the traits. If you use the traits as the data, means we can also extend the data from multiple resources. Fine. On top of this, let's check it out. We have some of the concepts are there related to the additional features, like if you want to maintain, suppose if you want to pass one class object to the another classes, if you have the mechanism, if you have that much of mechanism, means that mechanism we are calling as a case classes. Let's check it out. What is the case classes and what are the key functions of a case class? I am writing a case class. Suppose I am taking the one class, suppose EMP is my class name. I want to define one abstract class. That class name I want to take it out as a EMP. Here I want to make the concept of case class. I want to make this EMP as a case class. What is the advantage we are getting means, this case class also a like regular classes which expose their constructor parameters and which provide a recursive decomposition mechanism via pattern matching algorithms. If with following the normal syntaxes itself, it will follow the things and which facilitate the normal facilitation. Write the normal class. In this employee class, fine, I am writing one more class, that is let us take it out as a manager. Fine, as the employee I have one of the manager class. I want to maintain one case class. Let's take it out. What is the advantage with the case classes? Case class, and here I am taking the class name as manager, and as a manager you people know, right? We have as a manager, let us take it out, I have a one ID. Fine, and as ID I am taking as a integer, and let us keep the some of the things like ID and name. Name is string. Fine, I want to do these case classes should be extends the normal classes. For this only I am writing extends EMP. In the same concern I am writing case class. I am writing one more case class. In EMP I have a normal employee. Below managers I have assistant managers also there. Assistant manager is also having ID, name. Fine, suppose let us take that. I am having ID and salary. Salary also I am taking as a integer or integer only, or else you can keep the double for salary. And same thing, extending a employee class. Fine, let's execute these classes, whether how it will be works or not. Check it out. Yes, class EMP has been created, and I want to call manager with the 101 and the name I am giving as okay. We have to create an object for the EMP class, then only we have to call the accessing of those classes. Fine, let's check it out with the, suppose again what we have to do is we have to create one normal class, and we do extend those EMP class, and we have to provide the manager and assistant manager classes. For this we have to pass the values to our classes only. We can directly pass the parameters to the classes. Fine, you have to do all these things, and you can use the wherever you want, as we can easily specify the patterns by using normal classes. When we are passing the values to the parameter classes only, not to the methods. Directly we are passing to the values to the parameters to our classes. Fine. Still we have a lot of things are there. Let's check it out. Remaining things later. Still we have seen a lot of things, right? Let's check out the lot of remaining things like case classes. Let's tell me about case classes and all things. These classes also a normal regular class itself. The main purpose of these case classes and where I can use it means, let's check it out. Suppose if you want to create a case class means, we can directly create a case, the class and the class name. Suppose the class name if you want to create is ABC. Like this we can already we can create it and we can make use. Fine. These are also a normal case, something like regular class itself. Fine. Where we can work with the some. Suppose if you want to pass the something like which exports their constructor parameters, and if you want to provide the recursive decomposition mechanism on top of these pattern matching algorithms, then only we have to use the case classes. If you want to perform the pattern matching techniques, and if you want to maintain the things in a, if you want to take the parameters as if normal to the directly to the case classes, then we have to use the case class. Suppose as a case class we will look like this. Suppose we are, this is not right. Suppose let's create one abstract class, and I am taking as a here I am taking this abstract class A as the some superclass, and I am keeping some of the methods in the class A. Fine. And after creating of the abstract class, why we are creating abstract class means we have to give the support to the case classes. The case class syntax will look like this. Case class, the class name I am keeping as suppose case A, and here as the case A we have to provide some class names, right? We have to pass the parameters directly to the classes itself. Suppose I want to be ID. I want to pass a ID for the case A. You can directly pass. No need to have the restriction. Defined class case A. Here and like this we can also pass case B if you want to pass name as string, and I want to keep salary as integer. Like this you can create this classes, case classes. Fine. And if you want to give the support purpose itself, what I want to do is I already created some abstract classes and we keep it some function definitions, right? We have to extend those case classes. Fine. Suppose let us create out case class case C. Fine. I am taking again, let us take the salary, and we have to get support from superclasses. Like what are the functions I need to override it. Fine. Like this we can create case classes and we do work with the superclasses. What are the superclass values? We have those classes we can directly pass to the classes. We do not expect from the primitives like methods and all things. Fine. If you want to execute a class A and call, if you want to perform anything means again we have to use the functions and all things, right? We have to pass the parameters of the function, then only we have to work with that. But no need to use all these things. We can also directly work with the case classes. We do pass the parameters as the directly to the our constructor classes itself, as we already seen the primitive constructors, right? Like this manner itself we already work with the case classes. Fine. In Scala we have seen a lot of concepts related to the case classes, related to class and objects. We have seen functional programming techniques like array buffers. We have seen a lot of techniques. Fine. As a traits, we have seen the traits. Instead of interfaces, we do support the traits to work with the abstraction mechanism, and we have to work with the multiple inheritance concepts in the Scala. For this purpose itself, we do support all the concepts, all the related programmatical things in Scala. For this purpose itself, Scala becomes most popular in nowadays. We already have a lot of programming techniques on top of Scala, right? Let's check it out in detail. What is the remaining things, most advanced things in the Scala.